Good morning. Today we are going to be talking about the really cool concept of blood types. So I'm sure everybody's heard of the different blood types. We've got type A, type B, type AB, and type O. And of course, everybody has a blood type. Now, may or may not know your own blood type, but you're probably at least familiar with the concept. And the idea of blood types is actually a great example of the concept codominance, which we learned about in the previous video. It is also an example of multiple alleles because we have four different blood types and they can combine. Um, in terms of the alleles can combine to create four different blood types. Now, what determines your blood type? Well, it has to do with these little things called antigens that are on the blood. And we're not going to go into too many details, but if you have the A antigen, you have type A blood. If you have a B antigen, you have type B blood. If you have both A and B antigens, you have AB blood. And if you have no antigens, you have type O blood. And those antigens have to do with immunity, and they also have to do with whether you can donate or accept different blood types. Again, we're not going to get into that too much, but blood types are really, really cool to talk about. And if you're interested, there is a ton of information out there on the vast expanses of the internet. You can watch videos, etc. But you've probably also heard of blood types in terms of crime scenes and forensics evidence. You can take blood from a crime scene and see if it matches a suspect. And it can also exonerate a suspect if their blood type isn't found at the crime scene, or it could prove their innocence or help at least prove their innocence. So, that being said, let's jump right into talking about the different blood types. So, we've got four different phenotypes: type A, type B, type AB, and O. And they have a couple different ways to write the genotypes. Honestly, this is the simplified way to write the different genotypes for blood. This column over here. This is the kind of the fancy way to write blood types. It looks super complicated. It really isn't, but it looks cool and it looks really sciency. So basically, what it's showing you is to have type A blood, you need to have two of the A alleles. And we write these A alleles with a capital letter I, and then we make a superscript with an A. So you can have two of those IA alleles, or you can have a capital IA allele with this little I. And if you go over to the right here, you can see a simplified version. So AA gives you type A blood, and AO gives you type A blood. Please note that this A antigen, covers up the antigen for O blood. If we move to type B, very similarly, we have these superscripts BB that would give you type B blood. And we have the superscript B with the little I. And again, BB gives you type B blood. BO also gives you type B blood. In terms of AB blood, this one's a little bit simpler. You have the A antigen and the B antigen, and that gives you type AB blood, simplified over here. And lastly, we have type O blood, which is just this little I, or OO. As we move on to some blood type example problems, these are really cool, in my opinion. We're going to start with the first example here. If we have parents with AB blood and O blood, respectively. So here we have a parent with type AB blood and then type O blood. And I've used this simplified version of the genotypes just to kind of help us out here. We do our Punnett square. And again, recall that the offspring, possible genotypes for the offspring, are in here. So we list those out, and we have these as our possible two genotypes, AO and BO. So again, both of these offspring are carriers for type O blood, but they do not have type O blood. AO would be type A blood, and BO would be type B blood. If anybody's feeling particularly fancy, you can see over here I've used the I with the superscript A, and then I with the superscript B to represent AB blood. And then I've used these little lowercase i's to represent type O blood. The results are the same, it just looks a little different. Again, this version being a little bit more simple, and this version being a little bit more complex. If we take a look at the next example, it says, could two individuals with type A blood have a baby with type O blood? Well, we have to think about the two possible genotypes. And please note, I used the fancy lettering. I was feeling a little fancy here, but to have type A blood, you could have a superscript A with a little I, or you can have two superscript A's. Now recall that in order to have type O blood, you'd need to have two of these little i's. So if we take a look at our Punnett square here, we have essentially the A allele and the O allele, the A allele and the O allele. If we complete our Punnett square, we look at the offspring here, and we see the possibility of having type O blood is a 1 out of 4, or a 25% chance. So the offspring have a 25% chance of having type O blood, even though the parents both had type A. Because again, both of these parents have the O antigen, we just don't see it, but it's there. So that O allele is there, we don't see it, but the babies could hypothetically have type O blood. So yes, this is possible. Okay. Again, feel free to reach out with questions. I will be uploading another video with some additional blood type examples. Thanks so much.